Okay, so in this video I'm going to talk about Project 1 and the requirements that you have to do for Project 1. So the idea for Project 1 is, and for all the projects, is to be able to use the techniques that have been discussed in the different modules to actually work on something that would be of interest on a research problem. So basically this is a research problem that has guided instructions. So typically a true research problem then you don't really know what's going to happen, and the research takes you in all different kinds of directions. So I've been very specific about, I want you to do this, this, and this. And so I'm going to tell you what all you need to do in this project. It's open-ended in the fact that what you find from it and what you conclude from it are basically new information and how you interpret it, what you see, and all of that. But it really is based on some kind of research problem that people were interested in, and in this case in a university. So what you're going to do is you're going to model graduation or graduation rates, or the probability of graduation from a local university using a discrete time Markov chain. So I'm just going to give you some highlights from this. You can read it all by yourself. One of the first things I want to point out that all projects are individual work. So on assignments, I allow you to work with other people. Projects, however, are all individual work. The only person that you can ask for assistance is myself. Okay, so in this project, you're going to write a report. So the report should be like a research paper. So you should have some kind of introduction. You should be introducing the problem. So in this case, the problem is how to look at graduation from a local university, or the progression to graduation. Not necessarily graduation by itself, but the progression to graduation. And so you really want to tell a story. And I walk you through how to tell that story in this. And so, yes, this is a long description of what you're supposed to do. I agree. But it's only because I walk you through what I'm looking for. Okay, so I have given you 3 data sets to work with. One data set consists of information about undergraduates, all the undergraduates at a particular university. One is only for a specific college within the university, so a subset of that data set, and one for just a set of undeclared students in the university. So again, a subset of all the undergrads. So what I want you to do is break your report into different sections. So like I said, I want you to give an introduction. I want you to explain why you would actually be looking at the progression from freshman to sophomore to junior to senior at a university. What would motivate this? Why would people be interested in this? And for our particular class, why would you actually use a discrete time Markov chain to do this? What is it about a discrete time Markov chain that makes this something that would be good to use for this kind of study? Okay, so then the next section should be the model development. So you have 3 different data sets. You're going to have 3 different models. One model is going to be for all students. One model is going to be for college-specific data, so the data that is just for the specific college. Another one's going to be for the undeclared students. So the reason why you have 3 different data sets, well, actually that's what you need to explain, is why you have the 3 different models for the 3 different data sets. So I should not give you the answer to this question, so you should figure this out yourself. So for all data, I expect that you're going to have the different states: freshman, sophomore, junior, senior, dropout, and graduated. So those are the states that you should consider for all student data. For college-specific data, then I want you to have the states: freshman, sophomore, junior, senior, dropout, graduated, and changed major. And for the undeclared students, I want you to have freshman, sophomore, junior, senior, dropout, and changed major. So these are going to be the states that you're going to look at for these different Markov chains. So each one of these are different because they have different state variables that you're going to be dealing with. So for each of these, you need to draw a transition diagram. So I've given you code that actually finds probability transition matrices. So you should be able to use those probability transition matrices that are outputted from this code to help you in forming this diagram. You should probably already be able to think about how this transition would go, but you may get something slightly different than what you would actually imagine once you look at these probability transition matrices. So even though it's not exactly what you would think it should be when you look at the output, it's what the data says it should be. So just keep that in mind when you actually look at these probability transition matrices. So you have data that starts in fall 2008 and goes through spring 2009. So the things that you need to do are look at the transition matrices, figure out the transition diagram, identify what time increments you should use for your Markov chain. So should you use days, months, years, semesters, etc., etc. And for each model, you need to identify all the classes in the model. So we talked about classes of discrete time Markov chains, determining whether or not your model is reducible or irreducible, figure out if there's any absorbing states, determine if the classes that you've identified are recurrent or transient, what are the periods for the classes. So all the information that you've actually done previously, you want to do on these models. So you're going to have 3 different models. So basically in this section, you want to clearly explain the development in the model. Why are you using the model? What's all involved with the model? What are the different states? Why you use the different states, etc., etc. Okay, so now you want, in the next section, you want to interpret the transition matrices. So you want to specifically explain the transition matrices. And for the particular models individually, why do the transition matrices look the way they do? So some of the things that you need to think about are, is the transition matrix similar from one semester to the next? So you have fall 2008 data, spring 2009 data, fall 2009 data. So you're assuming one to the other. We do not have summer semesters here. So you have different transition matrices for each semester going to the next semester. Are they the same? Are they not the same? Why does it make sense for them to be the same or not the same? Do you expect this, or did you expect something else? So then what do the entries in the matrix tell you about progression towards graduation when you're talking about being a freshman, sophomore, junior, and senior? From semester to semester, I give you a code that actually gives you the median of like all falls to spring, or the median of all spring to fall matrices. So do the entries vary much? Do you expect them to vary much? I also give you the code spits out the minimum and the maximum. So the way the minimum and the maximum are calculated is by just looking at, I have 5 different matrices for going from fall to spring. So I have, for the entry freshman to sophomore, I have 5 different entries. Do they vary much? So you're looking at the variation in the particular values in the matrices across the different years. Okay, so now in the model for undeclared students, I tell you some of the entries that concern you as you vary across time. So my question is why should they concern you? I'm telling you they look odd, so why do they look odd? Do you think this is the right model? If not, should it be something different? Why or why not? So explain your reasoning here. And then in your opinion, based on what you interpret from the matrices that you see, what do you think that people should do in the specific colleges or in the university to improve graduation rates? Where should they focus their efforts? Where do you see problems? Do you see any problems? Okay, so then also in the same section, we want to think about yearly probability transition matrix. So what is outputted from this code is semester to semester transition matrices. So how do I get the yearly transition? So if I'm going from one fall to the next fall, how do I calculate that using what is outputted from the matrix? So I want you to give me 5 different transition matrices for each of these 3 models. Yearly transition matrices. And does the yearly transition matrix tell you something the semester to semester transition matrix didn't? Is it giving you different information? Why or why not? And so then I want you to use the exact matrices. So exactly fall 2008 to spring 2009, spring 2009 to fall 2009. Use those exact matrices. And then instead of using that, use the median matrices. So I gave you median matrices. Use the median matrices to calculate this yearly transition matrix. Is it the same? Is it different? Is it too different? Explain. So then I want you to do 4 and 5 year probability transition matrices. So use the matrices generated from the code and figure out how to compute the probability transition matrix for 4 years. So what you would expect after 4 years or after 5 years. And so what does this mean? Discuss each of the classes, so each of the freshman, sophomore, junior, senior, and the probability of graduating if it's starting in one of these classes. Is this what you would expect? Is this what you would like? Is this what you would hope for if you were a university official? So now you do this also with the exact matrices and with the median matrices. And then how do you interpret what you get if you do this for undeclared students versus the college or the university? So we also need to talk about long-term effects. So for all these models, you want to calculate the steady state. So use the median matrices and calculate the steady state. Also calculate the mean time to absorption. So you should have some absorbing states. Calculate the mean time to absorption in these. And what's the probability of absorbing into one state or another, depending upon whether you're talking about a person being a freshman, sophomore, junior, or senior. What's it mean? So then you want to compare the entire university, what you get for the entire university, with your particular college and with undeclared students. And so based upon all the information that you have, that you generated in section 3, what do the differences tell you? Do they tell you anything different? So typically universities focus mainly on undeclared students. Should they only focus on undeclared students? Why or why not? Discuss the similarities between the college, the entire university, and the undeclared students. Discuss the differences. Hypothesize as to why there are similarities or differences in these trends that you're seeing. And then give a conclusion. So you want to give a summary of what you've done in the report, first of all. So reiterate why you're examining this and summarize the results. And then typically what's normally done is you normally do a sensitivity analysis and you figure out if I change some entry of my matrix slightly, what does this do on the long-term effects, the steady state, or the mean time to absorption, etc., etc. You don't have to do sensitivity analysis in this, but what I want you to think about is, in doing the sensitivity analysis, what might be your outcome of interest? What might you be interested in looking at? Also, can I really just change one probability in my matrix itself? Why or why not? So these are the different things that I want you to look at and want you to think about, and want you to think about what you would do in the future if this were your own research project. Okay, so now the MATLAB files I gave you is I've given you data. So I've given you different data sets, and in each of the data sets you have different terms. You have the term of the students, you have identifying numbers for students, you have whether or not they graduated, and you have a class. There's no header in these files just to make it easier. So I've given you all these different data sets. I have listed on D2L which college you should be looking at. So everybody's going to be using this all student data and undeclared student data. And then you need to find your name and figure out which one of these 4 colleges is your particular college to be examining. Then you have these different M files. And so here I explain all the different M files and what they output. And just as an example here, so this is one of the files. This is the Get Probability Transition Matrix, all students, all semesters. So here I've commented this, and so you should be able to go through and look at the comments and try to figure out what exactly is going on in this and what happens when I run it. Now for your specific college, so I also have semester to semester. So the difference between this data file for all students, I go from 1 to 10. So I go through all the semesters of the data. You have like a fall to spring only. So here I just skip. So I go from my fall, and then I go to my third semester, which is my second fall, and then I go to my third fall and my fourth fall. And I also have this for spring to fall, which I start with my second one, which is my first spring, and I go every other spring. Okay, so then the other thing that I have is for the particular college. Notice it uses this data importer. So for the particular college, you have to uncomment whichever one of these you're supposed to be using. So if you're supposed to be using AS, uncomment that one. If instead you're supposed to use the education, uncomment that one, and then save it. The only one that you have to run is this one. So you can run this and you can get the output. Okay, so I think that is a good overview of what you're supposed to do. Just to remind you, I have given you some time to do this. I have taken off one of the assignments, made it optional for you, and you have until October 19th by basically midnight to complete this. And so I want you to take your time on it, but I want you to also ask me if you have any questions on any of this.